Hello, welcome back to Math 7 with Mr. Passon. Today we are continuing our volume unit and we're going to be talking about a composite object. So even a three-dimensional object can be considered composite. And that means that three-dimensional object is made up of simpler objects. Now we're going to think of a couple different ones that you could think of, like a three-dimensional object that looks like it's made up of simpler pieces. My favorite is the I-beam. They use those in construction. Another one you might think about is a silo. It's made up of cylinder and then it's got half of a sphere on top. Another possible shape might be, I don't know, like an L shape, an L bracket. It's made up of two parts. Each one is a prism, but they make an L shape. So you can think of lots of options, or lots of objects that are made up of a collection of simpler shapes. Now, the volume of a composite shape can be found by adding or subtracting the parts. So we're often going to visualize the shape and we're going to think of, hey, can we break it into two pieces, or can we think of a large shape and subtract a smaller shape from it? So in this one here, I have a couple of options. I can sort of cut it this way, right, and cut it into this rectangular prism and this rectangular prism. Or, if I delete that one, I can cut it this way and cut it into this rectangular prism and this rectangular prism. Or I could think of this large prism made up of, and then remove, it would help if I got that looking good in parallel. If I took this large prism here and just removed this little corner. Alright, so we can think of this one as being made up of two smaller pieces, or as being a big piece with a piece removed. Now, most students are a little bit more comfortable with taking a piece and breaking it into smaller pieces. So we're going to break this one into two pieces, just like so. Okay? Now, here's where a lot of students might get confused. What is the length of this prism? Well, if you're looking at this 20 is actually this piece and this piece. So we're not going to use this 20 anymore. All right? We're going to think of that as being, and let me grab my little, that's not what I want. I want the little scribble one so I can draw on it. As being 12. Oh, I should just add a text box. What am I thinking? Text box. So we're going to think of this side as being 12 millimeters, and then this side being, well, 12 plus what is 20? This side is 8 millimeters. Oh, and let me stretch that out so it all fits. So we're not going to pay attention to this 20 anymore. We're going to think of this 12 and this is 8. Now, our formula, well, both of those are rectangular prisms. Okay. All right, so the volume formula for a rectangular prism, it's always the area of the base times the height, but that becomes length times width times height. So for this first one over here, it's 8 by 12 by 6. So our volume equals 8 times 12, that's our base, times 6 is our height. Okay? For this one, we're going to use that same setup. Volume equals length times width times height, except for now, or we're going to use 8 by 8 for our base, and then it's 16 tall. Okay, so it's 8 on this side, and 8 on this side, and then 16 this way. So we're going to go ahead and compute those, and I'm going to grab and do those on a calculator. So for this first one, I get 576. Oh, not 567, 576. And this is going to be millimeters cubed, and control period gets me my exponent. Then on this one, I get 1,024 millimeters cubed. Again, control period gets me my exponent, and control period gets me back down. Now I need to add up those two components, and I get that my total is 1,600 millimeters cubed. Again, control period for the exponent. Or so 1,600 cubic millimeters to fill up these two shapes combined. Alright? Now, think about how you would apply this one. Well, so go ahead and think it out, fill it out, and then we'll talk about it in just a moment. Pause the video. Okay, so this shape is made out of a rectangular prism and a triangular prism. So we would find the volume of each, and add them up. Okay, so this one would be length times width times how far we go in the opposite direction, and this one would be the area of the triangle times how far we go in that opposite direction, or that perpendicular direction, and that's how we do that. So now we're going to go ahead and go on to our next slide. Okay, so determine the volume of the objects below. Be sure to label all the missing dimensions first. Now it looks like this dimension is supposed to be 1 foot on every side, so I'm going to think there's a 1 here, a 1 here, and a 1 here. Okay, so let's look at this, and this is 1 foot, 1 foot, and 1 foot because it has to add up to 3 feet. So there's lots of 1s everywhere, but let's cut this into pieces that make sense for us. So let's cut this strip down here. And then we're going to cut this one here. So we're going to cut it into 3 slices. So this one, step 1, is 1 by 1 by 3. Okay, so step 1 is 1 by 1 by 3. Then our second step, step 2, is 1 wide, 2 tall, by 3 across. So 1 is 2 times 3. And then step 3 is 1 wide, 3 tall, and 3 across. So 1 times 3 times 3. So the volume of this one is 3. The volume of this one is 6. And the volume of this one is 9. So the total volume is 18 cubic feet. Okay? Now, if you're in a system that does not allow you to write an exponent, then you can still write your answer as cubic feet this way. So you don't need to have the ability to write a superscript to write your answer correctly. Let's look at this one. This is the only example that we're doing today that it seems a lot easier to find the volume of this whole thing and then remove the middle piece. So we're going to take the volume of the large component and remove the middle. Okay, so the large one is this big rectangular prism, and it's going to be 18 times 18 times 6. The middle is a cube, so that one is going to be 6 times 6 times 6. And let's go ahead and read through that again to make sure we got that right. A prism has a cube-shaped hole in the middle. The cube measures 6 by 6 by 6. What is the volume of the prism? So we want to take that big volume and remove that little volume. And again, we're going to use a calculator to get those pieces. So I've got my first volume is 18 times 18 times 6. So this one is 1,944. And then this one is 6 times 6 times 6, which is 216. And then, well, this time, because we're removing something, we are going to subtract. 1,944 minus 216, and that's going to mean that my difference, my volume, equals 1,728 cubic centimeters. All right. So this last example we're going to go over in just a moment, but read through it. A wooden toy is shaped and decorated like a house. How many cubic centimeters is the wooden toy? So we've got two parts, rectangular prism, and let's do that part first. And that's going to be 7 by 9 by 15. Volume equals length times width times height, which is 7 times 9 times 15. And again, I'll go ahead and do that calculation real quick. And that is 945. Then we've got our triangular prism. So our volume equals the area of our triangle times how far we go in the opposite direction. So our triangle is 8 times 5 divided by 2, which is 20. And then times how far we stretch in the other direction, which is 15. So we've got 20 times 15, and this part equals 300. So our total is 945 plus 300, which equals 1245 centimeters cubed. So that's 1,245 cubic centimeters. Summarize what you've done today. It should make sense, hopefully, that you can make complicated shapes by breaking them into simple shapes, and that should make it easier to do.